All right, we are moving on to our last day for our lesson number 1, talking about counting items, either using and to count and establish our sample space. And we've talked about already tree diagrams, organized lists to create the sample space, and then counting the elements in the sample space. Then we have other tools to use. We have factorial, permutations, and of yesterday, combinations. Today we're going to work some more on the combinations, and our warm-up is going to be counting different types of cards. So here we have laid out for us a standard deck of 52 cards. So we have 1, 2, 3 rows, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns. So we have 4 times 13, which would give us 52 cards total. And when they talk about a standard deck, this is what they're talking about. There's no jokers or any funny business. Okay, each suit, so that's one of these rows here, our clubs, our spades, our hearts, or our diamonds. Each one of those has 13 cards. These are the face cards, because they have a face on them, not just a number. There are 3 by 4 face cards, or 12 face cards. Half of the deck is red, and half of the deck is black. So 52 divided by 2 is 26. So we have 26 of each color. There are 1, 2, 3, 4 of each kind. You can see in a column there's 4 rows in each column, and they have the same card, just in a different suit. And there are how many non-face cards? So we would take the 52 minus the 12 face cards to get 40 regular cards, we'll call them. There are blank cards of each suit. That's so many of each: club, spades, hearts, and diamonds. Again, that's really the same question as this one. Each suit has how many cards? So there are 13 cards in each suit. And now we kind of have to think about how stuff plays out. We have how many cards that are both red and a 6. So we would look in here. I have 2 cards. Well, I have 4 cards that have a 6 on them, but only 2 of them are red. So there's 2 cards that are both red and 6. Then we go over to the face cards. We need to see how many qualify. They have both qualities. They are both black and a face card. So then I'm just looking at the black ones up here, and I have 1, 2, 3, 4, 5, 6. Or another way to think of that is we have 12 face cards. Half of them are red and half of them are black. So we have 6 that meet that criteria. And then finally, how many cards are both hearts and a face card? So we would go to the hearts row and we count 1, 2, 3 face cards. So this is a really good reference tool to have here. I know in your note packet, if it's black and white, maybe you just need to write the colors next to the different suits if you don't play cards. But this will be important because we'll need to count things up for our combinations, our hands that we're going to be making, and eventually for probability. So again, each card has 52, or each deck has 52 cards. There are 13 of each suit, 26 of the same color. The 2 colors we're talking about, black or red. When talking about dealing a hand of cards, order is generally not important. So we will be using combinations for these cards type problems. Okay, and sometimes it'll say at the beginning of the problem that order is not important. Sometimes you're just going to assume it. So if the order in which the cards are dealt is not important, determine the number of possible different 5-card hands. Okay, that means that you are going to get exactly 5 cards. And we're going to use a combination to calculate this because the order is not important. There are the 52 cards in the deck. So this is like our N, our population that we are selecting from. And then these are the ones that we're going to select. These are the cards of interest. And this is pretty straightforward. There's no conditions here. You just get 5 out of the 52. You can use the formula or you can get your calculator and put in that combination, and you're going to get a pretty big number. Okay, again, we want to determine the number of 5-card hands when all 5 cards have the same color. Okay, so inherently I'm thinking I'm going to have less than I have here because I have more conditions placed on what type of cards I'm going to have. And I'm thinking 2 things have to happen here. We have to get the same color, and then out of that color we get our 5 cards. So one way to think about that is to first, out of the 2 colors, black or red, we're going to pick one of them. And out of those 26 black or red cards, we want 5, because we want them to all be the same suit. Okay, another way to think about this would be, okay, out of the population of 26 of all the same color, you're going to choose 5, but there are 2 populations of 26 cards of the same color. So whichever one makes more sense to you, we get our calculator and we get our total. And I can see that 131,000 is significantly less than 2 million. Determine the number of possible 5-card hands that contain 5 face cards, kings, queens, or jacks. Okay, so now our 5-card hand is chosen from a small group of cards, kings, queens, or jacks, these face cards. There are 4 of each of these cards, or 12 cards in total. So our combination is just being taken from a population of 12, but we still want all our 5 cards to come from that 12. Now again, I'm thinking I should be probably smaller than the one before. This is a more restrictive group that I'm choosing from. Here I had 26 to choose from, and 2 groups of those 26. Now I have one group of 12 where I have to get all 5 cards. That in your calculator, and you get 792. Now we move on to determine the number of possible 5-card hands that have either 5 hearts or 5 diamonds. I am not seeing an and, I'm seeing an or, which to me means I have options. So my options here are to create a 5-card hand that has all hearts or has all diamonds. So we have to treat each of these separately, and because of the or, we're going to add those options together. So here is the first population we're picking from. These are our heart cards. There are 13 of each suit. So out of those 13, I would need to choose 5 of those. Or I could go to my other suit, which would be my diamonds, and choose 5 cards out of the diamonds. Again, you can, this is a special situation where both populations have the same amount, so it would be okay to think about, I have 2 groups that I could choose my 5 out of, so you could kind of rewrite it as the one above, where we have 2 suits, each with 13 cards, and we're going to choose all 5 of our cards from those one of those 2 suits. So again, to recap, when we see an and, we multiply. When we see an or, we add. Card problems in general are combinations. Okay, one more thing we really kind of want to talk about, and then I'm going to let you kind of go on this on your own, is this idea of at most and at least. And these are 2 special cases. I mean, what we've done so far is we've been talking about getting exactly what we wanted. Exactly, 4 face cards. Exactly 5 cards of the same suit. Here, we've got a little bit more flexibility. If we think about the phrase at most provides an upper limit. The phrase at least, which is the opposite, provides an opposite limit or a lower limit. So something that may clarify, if you need a score of at least 94% on the semester exam to get an A for the semester, any grade that is greater than or equal to 94% will get you an A. So that's your minimum requirement. On the other hand, if a quiz has 20 questions, then you can get at most 20 correct. That's our upper limit. So if we look at William Shakespeare, he wrote 38 plays that can be divided into 3 genres or types: comedy, history, and tragedy. Of his 38 plays, 18 are comedies, 10 are histories, and 10 are tragedies. First thing we want to do, let's do an exact one. We should be able to do this pretty easily. Determine the number of different sets of reading exactly 2 comedies and 1 tragedy. So again, I see that word and, I know I'm going to be multiplying 2 different combinations. So go ahead and write the 2 combinations and multiply them together, and then maybe check with a partner to see if you got the right answer. So again, we should have 2 separate combinations that we're going to multiply together to get our answer. The next one, it says determine the number of different ways we can read either 2 comedies or 3 histories. Again, I'm having 2 combinations, but because I see the word or, I'm going to be adding these combinations. Now for the at least, at most. Okay, determine the number of ways we can read at most 2 comedies. So the 2 is my upper limit. So the scenarios in which will make this true, we could read no comedies. Or we could read exactly 1 comedy. Or we could read exactly 2 comedies. And because of the ors, we are going to add these options together. So out of the 18 comedies, I choose to read none. Or out of the 18 comedies, I choose to read 1. Or out of the 18 comedies, I choose to read 2. And we could put that all into our calculator and get the correct number of ways this can happen. So let's go ahead and try this one. How many different sets of at most 3 plays you can read? So I'm thinking I could read 0, 1, 2, or 3. So those are going to be the combinations here. And then I'm going to put that in my calculator. And then we'll go ahead and let you read through that last page there and fill that in. Some really neat things that you'll see about how these combinations work by looking at the 10 tragedies and reading at least 8 of them. So I want you to really spend some time reading through this last page, and then we have our exit slip.